Hello guys, my name is Yakov Fein. I work for a company called Farata Systems. Today is lesson number 13 from my series Intro to Java Programming. 3 topics we are covering today: how to work with Swing JTable, what are Java annotations, and what is Java reflection. These subjects are not exactly very related to each other, but these are like bits and pieces that I don't want to miss out. We need to talk about these. Swing JTable is a very powerful component of GUI framework Swing, and for enterprise application it's one of the most important components, because we usually program for enterprises, different kind of grids, reports, so when we need to show the data in rows and columns. Why do I want to teach you JTable now, even though Swing framework was covered long time ago? The reason being that last lesson was about relational database management systems, where the data is stored in rows and columns, in tables. So rows and columns are pretty easy to display in grids, which also have rows and columns. The intersection of every row and column is a cell. So these are the, look at this example, stock quotes, rows and vertical columns. Each column has a name. If the data will be coming from the database, the database table names will dictate, or at least will give us an idea how to name the columns in the report. Say this is a report and stock quotes. JTable is the main component that is needed for programming such grids. Before moving forward, I'd like to tell you about this design pattern. Most likely I already mentioned it before, but let me do it again in a little bit different context. MVC, very popular design pattern, meaning what? M stands for model, V for view, and C for controller. What are these guys? It's about how to slice your code into separate layers. For example, the trend is you need to keep the classes, the code that is responsible for displaying the data, for the view in a separate place. You need to keep the classes that are storing data, which is M model, separately, and C is a controller. Controller is something that brings it, that moves the data from the GUI to the model, to the collection of data, or from the model to the GUI. And to program JTable, you need to have 2 classes. One of them should be an instance of JTable itself for view, and the model is represented by the interface TableModel. You need to have a class that implements TableModel. And Java Swing conveniently gives you a couple of options already, pre-created classes. So controller, say you have a button on the screen, J button. You click on this J button and the data is populated on the screen. So data comes into the grid. Or you make some changes on the UI, you as a user. Press the button save or update the data is being moved from the view to the model, and maybe then later on to the database, some kind of a data store. So in this case, the click on the button will start the controller, which hopefully has the right code to move the data in the right direction. Swing classes, default table model, and abstract table model already implement table model interface, as I said. Default table model most likely you won't be using. It has very limited features, but what you will be doing most likely, you will be creating a class that will extend abstract table model, and you will arrange the data in there. The data that you are planning to display on the UI, on the GUI. So JTable will know about its model. JTable will receive notifications from table model whenever something is changed, whenever the data is changed. Okay, next, how to do something like this. Let's look at the code. For example, we have a class which extends extends JFrame and implements table model listener. Let's take a look at this code. The first part is pretty simple. You understand JFrame is the Swing GUI container. You declare a variable of type myTableModel by looking at this class name. We probably can guess that this is a place where the data will be stored. And where is this class? It's right there, down there. Check this out. It's an inner class. The class myTableModel is located right inside the class myFrame. It's an inner class, but not anonymous inner class. Why did we even put this one class inside the other? Just because the class myTableModel is pretty much useless anywhere else. This class serves the only purpose to store the data to be fed to the class myFrame, or to be more specific, to the JTable. JTable component is declared right there. And when you will be instantiating these classes, myTableModel, you instantiate the class, and then you give this class as an argument to the instance of JTable. So JTable knows where its model is. Okay. Now, as you can see from the class declaration, it implements TableModel listener. TableModel listener. If you look at the documentation for TableModel listener, you will find there a method, table changed. So you have to, if you said that you implement this interface, you have to implement the method table changed. And this class will be a listener to the table. So whenever it changes, the event will be fired. You'll see it in 5-10 minutes. And whoever is a listener, whoever is interested to know that data is changed, will get a notification. For now, just remember that we implement TableModel listener. If this class implements it, then write some code in table changed event to do something when the data is changed. For example, the user changed something on the screen. What is the model? How you can create a model? Any way you want it. You can declare some variables and put some data in there. This is a model. You can create a collection of data, like in this case, I have created an array list of orders. Maybe this JTable will display orders. So in this case, I am displaying a list of orders. I'm having a list of orders, assuming that I have a class order. I created 4 instances of the class order and add them all to the collection of the type array list. These orders should be displayed in the JTable. This collection array list will serve as a model for my JTable. You'll see it in action pretty soon, in hands-on. Mandatory callbacks. When you will be implementing JTableModel, when you will be creating JTableModel, by creating, I want to remind you that you will be extending abstract table model, and you will put something in there. So what is mandatory? You have to put in there at least 3 methods: get column count, get row count, and get value at. What are these? These are callbacks, meaning that you will never invoke them directly. They will be invoked on your class by Java runtime. Whenever Java runtime decides that it types to populate the screen from your model. So whenever it needs to allocate space on the GUI to display your rows and columns from your table, it will start asking your class, your table model. It'll ask, tell me how many columns you want me to display on the screen, and you have to return a number, how many you are planning to. And then it'll ask you, Java runtime will ask your class, tell me how many rows you are planning to show. You will have to write a code that will return the number of rows in your model. And then Java runtime, one by one, will be calling the method getValueAt on your model to get the value to be displayed in each cell. A cell is again intersection of a row and a column on the JTable. So for every values of a row and column, it's your responsibility to write code in there that will return the proper value for display. Two terms that you need to remember: renderers and editors. These are not specific for Java Swing, it's general terms. When you are rendering GUI, it means that your program puts stuff to display. It could be a browser. In this case, it's not a browser, it's just a standalone application. But we are rendering content to be displayed. If we talk about the reverse process, say a user is entering something on the screen, and this data should be forwarded to the back-end code, to the code that is behind the scene, that is not visible, then we call this editor. So if you want to allow users to edit your JTable, then you will be using either default editors or you can create your custom editor. The same with renders. By default, all renders for JTable will be displaying the content as JTable. So technically, before placing the data into a cell of JTable, Swing Render will create an instance of JLabel and display the content in there. So technically, it will display everything as text in the cells of the grid. Text may be fine, or maybe it's not that great. Maybe you need to create custom renders. For example, you may want to create a custom renderer if you want to have a cell in a grid about the employees in your company. You want to have a cell that will display the name of the person, and right under you want to display an image, a photo of this person. And it's still, in every row you will have a record about one employee, but in one particular cell you don't want to have text, you want to have two components. On top you want to have text to display the name, and at the bottom you want to display an image. That's a perfect case for creating a custom renderer. Otherwise, Swing will not know how to display images. You need to create a component, and you need to say, when it's time to display the name and the photo of the employee, please use my custom renderer. I've written it here, and this is how you're supposed to render this particular cell. On our slide, you will see an example. I show you a little bit different example, explaining how can you paint in different color the value of the cell based on its value. For example, you display information about the stocks, right? And you want to display the stocks with the price greater than $100, you want to display them in red. If the price is less than $100, you want to display this particular cell in black. And see, we need some flexibility, because it's not like something like written in stone. It's not like for the column you can say this column is supposed to be this wide and this font family and the font, and these are the color. No, you want to fine-tune the rendering on the cell level. Today something is more than $100. Tomorrow the data behind the scenes in the database is different, and then you will display this data in black and not in red. How to do something like this? To create your own custom renderer. In my case, I'm saying I want to assign a custom renderer to the column in a model with index 3. Since everything is zero-based, we understand that we're going to be assigning this custom renderer to the column number 4, column number 0, 1, 2, 3. There's the fourth column. Now, so you get a reference to the fourth column of the table model, and then you're saying to this column, dear column, I want to assign to you a different custom renderer. How to do this? You create a new instance of an inner class, right? And in there, as this is going to be called back, by the way. Runtime will, when the time is to render this column, it'll find this renderer and it'll start passing you the value to your renderer. So it'll give you a reference to the table. It'll give you a reference to the value to be displayed. Boolean flag if this column is selected. Then if it has focus, and row and column of the coordinate of the cell in the grid. So in this example, we are getting first we are getting the label, right, from the superclass, and then we start adjusting this label, fine-tuning display, so to speak. First of all, we are saying that we want you to display everything pushed to the right. This is a column displaying numbers. Numbers should be pushed to the right, right? Then we say, let me check the value that was given to me by the Java runtime. If it's greater than 100, I want to paint this label in red, otherwise in black. And when I prepared my label to be rendered, I return it to the renderer, to the Swing renderer. Swing renderer knows what to do. We prepare this particular value, and it'll be put in the cell. This is how it works. Of course, if I wanted to create over here a situation when we have an employee with a name and the image underneath, you would need to create a container over here instead of JLabel. Inside of the container, you would need to put JLabel and some image control and render the entire container. That's the idea. You can find plenty of examples online. And now we'll try to do this custom render to see it in action. It's lesson number 23 from the textbook. And in that lesson, you need to import the source code into Eclipse, which I already did. It's right there. Lesson 23. Order is the data that represent our model. So we will display 4 columns: order ID, stock symbol, quantity, and price. And the price is the one that we will be painting red or black, remember? This is the constructor of the order. By the way, this is our so-called value object. Remember from the last lesson? I said go and do some study on DTOs, data transfer object, or value objects. So this is an example of a value object. Honestly, the purist may say it's not exactly a value object because you didn't provide getters and setters, and your fields are public. That's okay. This is how I want it. This is still a value object. Next, my frame. My frame is just a GUI. GUI has a table model, like on the slide. We create an instance of a table model and we pass it to JTable, right? Next, we are saying that this class will be listening to the event in the model. Next, when the event will be fired, that the model is changed, this callback will be invoked, and we will just print someone change the data in JTable. This is how I want to process, how I want to react on notification about the data change. Creating a frame, this is the simple stuff. And the model, this is the model itself. The table model extends the abstract model, right? So we put in there an array to keep the title for each column, and we populated the table model my data, creating 4 instances of the order, and we added them in the array list. That's my model. Also, as I said, the model should implement at least 3 methods. Whenever runtime will ask it how many columns you have, I'm returning 4 because I have 4 columns. Whenever runtime will ask me how many rows you have, I will return the size of the collection. And whenever the runtime will ask me, give me the data for this particular cell, it'll be calling getValueAdd, and it'll pass to my code the number of row and the number of column which is about to be populated, the cell coordinate. So what I do is I'm saying from that collection, I know that that collection has or orders inside, right? Instances of the order. So I'm saying get me the appropriate order based on the row, and from there get me an order ID. If the column is the second column, I'm saying get me the row and give me the value of stock symbol. If it's a third column, give me the quantity from the order. If it's a fourth column, give me the price from the order. Very simple, right? Get column name. Whenever a runtime will be calling get column name, I want to give the name that I put in my array of names for the column. It's right there, line 46 and 47. Anything else? Yes. You can control which cells in your grid will be editable or won't be editable, or read-only. So in this particular case, I show you how you can specify that the third column will be editable. Again, the is cell editable is a callback, which will be called by the runtime. And if you will return true for whatever row and columns they pass your code, then this column will be made, this cell will be made editable. And finally, I also implemented, it's not mandatory, but I implemented the code for the set value at. Why it's not mandatory? Because not every grid is expected to react on users' actions and is expected to be editable. But if your grid allows to enter the data, then you can provide set value at. Set value at with these three arguments. Again, this code will be called as a callback by the runtime. You enter the value in the cell, you tab out, you move the focus out of the cell, and the runtime will call this method for you. So in this particular case, since I made the column number 2 editable, then I am getting the value in this row. I convert the value in this row. Value will be given to me to the callback, right? And I assign the value, which this highlighted part is the one that is on the GUI. On the left hand side of the equal sign, you see the value in the model. So I assign whatever we have in the GUI to the proper quantity in the proper order instance in the model. As soon as I did it, I want to let the world know about it. I want to fire an event saying something changed in the model, right? So to do that, you create a new instance of special class TableModel event, and you fire it. You fire table change. You warn whoever is interested, whoever is listening to me, I want to tell you that the table model was changed just now, as we speak. And who's going to be listening to it? Us. The same exact class. In this case, that would have to be the case. So it has table change event. So we expect to see this output on the console as soon as I change the date. In this example, there is no custom renders yet, but let's see how this works. Let me run it. Beautiful, beautiful table, my test window. This, see, I'm trying to enter something in column number 1, 2, or 3. Actually 3, yes, index 2, right? We made it editable. So let me change the value. Now I'm going to tab out of this cell and pay attention to the console. We will be getting into the table change event. See, I hit tab out. Someone changed the data in the table. So we dispatch the event in the set value at. From there, yes, the listener got it, and it executed the code in the table change event. That's why we see this. Someone changed the data in the JTable. Now let's take a look at this example with a custom renderer, which we discussed over here. It's right there. We get reference to the column from the model, to the last column, number 4. Then we assign to this column custom render, custom cell render, create an instance of it, and we push it to the right, the value, and we check the value. If it's greater than 100, we want to paint it in red, otherwise in black. Let's look at the order. No, not at the order, sorry. At the model. Where are the data? By the way, let me kill the previous run. Look at this. We expect to see this row, the first and second row, in red because they are greater than 100, their prices. Let's see if the trick works. Yep, it did. See this? The first 2 rows became red. Why? Because custom render checked the value of the cell and painted it in red because it was greater than 100. Let me do one little change in the code. What if I want to change it? I want to paint only those that are greater than 200. Save it. Rerun it. See, the market situation changed, and now only 1 row is shown in black, in red, sorry. The one that is greater than 200. Excellent, excellent work, Swing. Let's go back to slides. On this slide, you see an example of financial dashboard. Financial dashboard is, if you will ever find yourself on the trading floor or in the place where financial analysts are working on the Wall Street, then you will see lots of screens on every desk, and they show different financial data in different ways. One of them is JTable, of course. At the bottom, look at this. At the bottom left, this is a JTable. I mean, could be JTable. I'm not sure if this particular one is done in Java, but pretty much it's possible. So check this out. I can see right there that this column, the third column, is custom render. It shows some charting. Now, last and change the prices, right? Some of them are green, some of them are red. Custom renders, right? So in these cases, they are, instead of just checking the absolute value, they are comparing the previous value and the new value. Maybe there is some data feed about the prices. Prices are changing all the time. So there is a data feed into the table model. And every time the data in the table model changes, the code can see if the value went down, we want to show it in red and show a little red arrow next to it. If the value becomes larger than it was a second ago or a minute ago, then we will show it in green and show the arrow up. This is some hot maps custom renders over here. It also looks like a grid to me. On the bottom right, this is a grid, right? So grids are important in enterprise applications. As a matter of fact, enterprise applications are mainly about creating fancy grid, filling the forms, and maybe some fancy reporting with charts, with GUI charts. If you can do these, you can do enterprise. So we are done with this topic. Of course, you need to read a bit more about it, but it's up to you. The time is yours. If you have a motivation to learn, you'll find it. Annotation. Second topic from today's lesson is annotation. What are these? What is annotation in general? It's about metadata. Metadata. Different objects may have metadata. For example, you created a document in some word processor. This document can have such metadata as who created it, when created it, what the company name that this document was produced by, what the department, and so on. Who was the editor of the document. This is an example of the metadata. If we want to know the metadata about your program, it's technically, we can say that the program's metadata is the data about your code, something that defines your code. And what is defining your code? Let's recall how Java, say, create instances of the classes. Just as an example. You have a class, you have a declaration of the class with all these methods and properties in there, and then you create an instance of it. You may create multiple instances of the same class. What's going to be behind the scenes? Behind the scenes, like a ghost, we will have a special class which is called class with capital C. One class will keep the declaration of the class, and instances of this class will not repeat the declaration of the variable and the methods. They will only remember the state of this instance, this particular instance. Member variables, values in the member variables. So, if I want programmatically to query, to ask the class, which is loaded in memory already, tell me about yourself, give me your metadata, tell me how many methods you have, how many variables you have, do you have constructors, maybe you are inherited from another class. If so, can you give me the reference to methods of the superclass? So all this is, what do I tell you? Man, sorry. Not that I want to say forget about everything I said, because I started to explain you about reflection already. But let's go back to the annotation. I'm not going to be cutting off this section. It is what it is. I want to be live on this recording. So annotation is the data about the data. So you can annotate methods. You can annotate constructors. You can annotate variables. By saying annotate, what do I mean? I mean you can put a special word, maybe a word with parameter. Annotation starts with the @ sign that you can put in front of the method declaration, maybe in front of the variable, maybe in front of the constructor or a class. Check this out. Most likely you've seen already something like this. @override, especially when Eclipse generated for you some code. It marks some method as override. I'll explain you what it is in a minute, but this is how it looks. This one, the functional interface, is something new from Java 8, for example, and so on. So this is how annotation may look like. They start with the @ sign. The annotations that comes with Java already are located in 3 packages. Java lang annotation, and Java X annotations. They are spread around. Some annotations are used by compiler, as I said. The compiler pays attention to the annotation in your program and does something about them. Some are used during the runtime. So compiler doesn't care about them, but during the runtime, say post construct or pre-destroy, if you are instantiating some class and there is a method annotated with post construct, it could be a command to the runtime to invoke this method right after the constructor is done. So this is an example of a runtime annotation. When you will be studying Java EE, Java Enterprise Edition technologies, then you'll see annotation everywhere. They are used so much. But let's take a look at the simplest one, override. What is override? Say you have a class text. You're familiar with this from the first lessons. And then you created a class NJText, New Jersey text, that extends text. And you are planning to override a method called text in there. So what do you do to override? You need to declare a method with exactly the same method signature in the subclass as you declared in the superclass. And you can say, so what? Yes, I know this and I will do this. Why would I bother writing this override? Why? Why would I do that? And the reason is that some people are young and they have very good memory, but I am not that young anymore. So I can forget easily stuff. So what do I do? What would I do? The old and grumpy programmer. I'm starting writing public class New Jersey text, extends text, and I'm saying to myself, Yakov, you need to override a method called text. But please don't forget to do that. So to make sure that I will not forget that I am overriding actually, I will start writing @override, and then I will write public double called text and the rest. If I did everything as expected, this override annotation will not cause me any grief. But if I have forgotten, I was planning to write calc text without arguments, but I've forgotten that I was planning to override. Remember, I'm old. So I will, all of a sudden, I will enter the argument in the parentheses. So what do I create? I create a situation with overloading, right? Which is not a crime, but if I would not add the annotation override, compiler wouldn't even bother warning me or anything. Compiler would think maybe he wants to overload the method. But if I've written override first and then the name of the method, compiler won't let me do this error, mistake, syntax error. Compiler will immediately complain. It'll give me an error like at the bottom of the slide. It'll say, what are you doing? You said you're going to be overriding stuff, so why don't you override it? See? So annotation override is for older programmers or for those with the attention deficit disorder. Custom annotations. Custom annotation is something that you can create, not those that came from Java, but you may create some new annotations that never existed. Let's see how you can create your own annotation. First of all, you need to declare it, and then you need to write an annotation processor that knows what to do with every artifact that was marked with this annotation. Of course, if we'll go back for a sec, override annotation was taken care of by the creators of Java. They include annotation processor for it. They know what to do and how to react if a method is marked as override. But if you will come up with something new, Java has no way to know what are you planning to do with your annotation. So you need to declare an annotation. You need to use it somewhere, of course, in the code, but you need to also provide an annotation processor. Let's look at the sample annotation. First of all, it also uses the word interface, but in front of the word interface you put @ sign. Say I want to define new custom annotation called my JDBC executor. In this case, I just write public @interface my JDBC executor, curly braces, and inside I can declare parameters, because annotation also, like a method, may have parameters. It can be one or more over here. If there is one, in this case I said one value. So to use it, I can later on, I can annotate in this example. I can annotate some method, sorry. In this case it's get employees. I annotated this method with my custom annotation, passing one parameter, SQL statement. So let's start from employee. For example, I want to create some code generator. You give me a SQL statement and I will generate Java classes and process results set for you. Isn't it nice? It is nice. As a matter of fact, I work for a company and we did an open source product for many years ago, and we keep using it when we are generating Java classes based on the SQL. It's called Clear Data Builder. If you will look for it, you'll find it. And we are not the only one. There are popular framework. I think I mentioned before during the last lesson the popular framework called MyBetis. MyBetis. You can annotate with SQL a method, and MyBetis framework will retrieve the data from the database, or maybe it needs to update them. If retrieve, it'll give you a collection of Java instances already. So you don't need to loop through the result set. Anyway, so you declare an annotation. Then above this annotation, you're saying when this annotation should take effect. If the retention policy is source, it means that this annotation is for the compile time. Compiler should look at it and do something about it. If the annotation would be, if the retention policy would be runtime, then it's for the runtime. Also, you can specify where do you allow to use this annotation using this target. See, we have a declaration of annotation, which is in turn annotated with annotation retention and target. So in this case, I allow my annotation to be used with methods or with constructors, which means I will not be able to use this annotation with class variables, with member variables. So on top you see an example of annotation declaration. At the bottom you see an example of a class that uses this annotation. Say HR browser, I call this class. But this slide doesn't have any annotation processor. So it's great that the syntax is correct, it's great that we can use it, but we need something that would be processing these annotations. Here's an example with the annotation that has 3 arguments. Say I decided to change the signature of my annotation, and it not only can take this SQL statement as an argument, but also a Boolean variable if transaction is required. And I said default is false. If I'm not giving this value, I would assume not, transaction is not required. Or maybe there is another Boolean flag if I need to notify something or somebody on updates of the data. Again, default is false. If I'll be using this kind of annotation in class H browser, I still can specify only one value for the first argument SQL statement, but the other two will be given to this class with values of false. In the past, to create annotation processors, you would need to use special tool called APT. Starting from Java 7, you don't need to do this. It's included in Java C itself. We are not going to be writing the code to serve as an annotation processor. It's a little bit advanced topic for this training, but obviously you can find tutorials on that as well. For now, I just want to tell you that you can create custom annotation, and this is an example of how annotation can be used. So will you have a chance to use at least annotation during this course? Yes, you will. You definitely will. Especially, as I said before, when you will be using Java EE applications, the server-side Java, or maybe you're going to be using Spring Framework, you will see plenty of annotations. Who created them? Whoever created Java EE or whoever created Spring Framework. Who created the annotation process for them? They did. So technically, unless you are planning to develop your own framework, most likely you don't need to create annotation processors that often or at all. But you definitely need to know how to use annotations. That's why I show you how you can use an annotation created by somebody. This part you must know. And by the way, when I'll be talking about reflection, I also will give you an example how you can figure out programmatically if a class has annotation or it doesn't. So let's move to the topic number 3, the final topic of our lesson, reflection, Java reflection. I want to be able programmatically query the class, who you are, what you have. I mistakenly started to explain you this when I was talking about annotation, but let me do it now in a clean way. So remember that when you create instances of the classes, there is another something that is loaded in memory, not instantiated, but loaded in memory, and this is a class with a capital C. So if you created a class text and you decided to create 10 instances of the class text, you will have 10 instances of the class text, which remember only the state, the values for each instance, and you will have all 10 of them will be sharing one and only declaration of the class text that will be loaded by the loader. This declaration of the class text will have a type of class with capital C. Sounds like Chinese for you, I'm sure. You'll see it in a minute. It's so easy and cool. So during the runtime, you can query about internals of the Java class, as I said, using this guy, class with capital C. You can read more about it by following this link, of course. Plenty of documentation. There is even a book. I remember I bought a book like maybe 10 years ago called Java Reflection. A very, very nice book. I don't know if there exists newer edition or not, but that book was cool. It helped me to have a better and deeper understanding on what's happening in Java. But let's do a hands-on. Hands-on is the best thing in the world. We have a class, person, with the method raise salary. And I have a class employee that extends the class person. And over there, as you can see, as a senior programmer, you can recognize the fact that we are overriding raise salary, right? Now, on the right-hand side, you see a program that I wrote to show you how can I programmatically figure out internals of these two guys, employee and person. As a matter of fact, I want to query the internals, the metadata about the class employee. So what do I do in this line? I load it in memory. Check this out. There's a class with a capital C, and it has a method for name. I don't know why they call it, it's misleading, but technically I would call this method load. So this for name loads the declaration of the class employee in memory. Load, not instantiates, just loads. After that, this variable C points at something in memory that has the employee's declaration. After that, we want to apply reflection mechanism. And by the way, when I am applying this reflection, they call this process introspection. When during the runtime I'm trying to figure out the internals of the class using reflection, the whole process is called introspection. So I'm doing introspection now. So I'm asking this C. Dear C, give me the declaration of the methods if you have any methods at all. And this getDeclare method will return you an array. Each object will have a type method in there. And in a loop, I print the name of every method. Sorry, signature of every method in there. See? Reflection. Then I say, dear C, maybe you have an ancestor. If so, give me a superclass. I want to see what's inside there. And then in the superclass, I'm saying, what's the name of the superclass? And I print it. Then I ask the superclass, dear superclass, how about you? Maybe you also have some methods. If so, give me the reference to them. I have an array and I can print them. I print the name, for example, the signature. In this particular case, I am printing just the return time because I'm return type because I am interested in what this method returns. Right? So we are doing the reflection. You'll see this in action in a minute. Moreover, not only we can query the class and ask, what do you have inside? Do you have a method XYZ or any other method? We can also invoke this method after getting a reference to it, programmatically. And in workflow number 2, we're gonna see all that, I guess. I believe so. Workflow number 2 requires you to import lesson number 24. I want to warn you that all these examples were downloaded 3 years ago. And when you will download it and import it in your Eclipse, you may see some, like the project marked with red. Why? Because the Java runtime that you have now is different than it was set back there. Or you may have a situation, with this particular lesson, I believe I ran into the issue, right time, Java compiler. When I imported this class, project, I had 1.4 in here, and because of that, it started to complain that an annotation were not available before 1.5. So change it over here to fix all these stupid errors. Let's see what we got. Employee, the one that extends the person, which has raise salary and change address, 2 methods. Remember that. Person has just the method raise salary. And which one I want, I guess, reflection sample. Reflection sample. Did we even go through this HR browser? I don't get it. Why I put it in annotation number 3? Let me see. I don't know why I'm running walkthrough number 2 with reflection first, to be honest with you. Something is messed up. Not that much, but it could be better. Reflection sample, right click, run as. See, look at this. I did an introspection. I loaded the method employee, and then I started query. Tell me your method, who is your superclass, and so on. And it obediently, this program printed everything. Not only I queried that, but what else I did, I even invoked a method. Check this out. I decided to get a reference programmatically to the method change address of the class employee. And I prepared parameters for this address. In this particular case, let's look at the employee class. The change address expects to get a string which is a new address. So if I want to call this method, I need to somehow pass the new address. Let's see. So I am to pass parameters to a method which you got a hold of using reflection. You need to prepare parameters in an array. So in my case, I know that I will have parameters of type string. Then I get the method, reference to the method change address, and I'm saying parameter types is a place where you're going to get your parameters. Parameter types array is a place for your parameters. So now this variable knows the reference about the method, and it knows the parameters, where to get the parameters. Then I need to populate the parameters. I have only one. The new argument is 250 Broadway. 250 Broadway. And what I do is, now I invoke this method. Check this out. Invoke. It's a special Java method, that exists with Java. What I'm saying, take the reference to the method and invoke it. Create a new instance, first of all, of the class. Remember I said there is a difference between loading and instantiating. The fact that in line number 7, we loaded the class, at this point, after line number 7, there is not even one instance of the class employee yet. The declaration of the class is loaded into variable C, but no instances there. And for classes that were loaded but not instantiated, there is a special method called new instance. This is how I create a new instance based on the class declarations from variable C. So what I'm saying, create a new instance, take arguments in the array arguments, and pass it and invoke on that instance the method, my method, which is change address. And as you can see, it was invoked and the new address was printed as 250 Broadway. New address was printed as 250 Broadway. If somebody will ask you during the interview how you can create an instance of a new object in Java, everybody knows that I need to use the command new. But you also can say I can load the class and then using the method new instance, this is another way of instantiating the class. Okay, this was walkthrough number 2. And runtime annotation process. This section is supposed to be before reflection. Why did I put it there? I don't know. Okay. Anyway, I hope you didn't forget about annotation yet. It was only like 15 minutes ago. You're young people. Let's look at the example with my annotation processor. We went through the slides already, right? So this will be the class my annotation processor is in the same lesson 24. the same lesson 24. First of all, the annotation. My JDBC executor. See, I created an annotation. Which is supposed to take 3 parameters, a SQL statement and 2 flags. And I say that this annotation, my JDBC executor, the retention policy is runtime. And I say that you can use it only in the method, only with the methods. That means that I can use it only in front of the method signature. Method signature is here, for example, in HR browser. This is a class that uses the annotation. I annotated this method with the annotation my JDBC executor. Right? So again, if I would have an annotation processor, I could do something nice about it, but I don't have it. This is another example. Second method, update data. It's also annotated with my JDBC executor. But in this case, I'm passing different statement, and transaction required, say true, and notify updates is true. So 2 methods are annotated. Finally, if I will run the program, my annotation processor, this program is halfway done. As I said, we will not have annotation processor, but at least we will cover how to discover if annotation exists in there. By the way, now I see why I put it in this order. Of course, you need to know the reflection to understand this subject. So the my annotation processor has to figure out if the class that you're going to give to this processor has annotations that you are interested in. How to figure it out programmatically? We are, say, creators of the framework. We have no idea who's going to be using our classes, our framework. So I assume that somebody will pass me the name of the class to parse, to introspect, to see if it has annotation. So I'm going to be giving the name of this class from the command line. Then I load the declaration of this class that was given to me, right? It's just load the class, no instances. Then I'm going to say in line number 20, get me the methods, reference to all methods of this class that you have. Fine. And now, starting from line number 24, I am looping through these methods and try to find. There is a special method called isAnnotationPresent. Does any of your methods has annotation? Not in general, but this particular one, my JDBC executor. And if it does, I get a reference to this annotation. And then I can query and ask, dear annotation, what is the method name? Method name we are printing. And then I can ask, dear annotation, what's the parameter which was given to you in SQL statement? What is the parameter that was given to you as notify on updates? What is the parameter that was given to you as transaction required? So technically, I am introspecting the class, figuring out which methods have annotations that I'm looking for, and what are values of their parameters. So this is an annotation discovery, so to speak, using reflection. Let's see. If we will run this guy, my annotation processor, or my DB annotation processor, see, it figured out that the class, by the way, which class? Let me show you so you understand. We were supposed to pass it from the command line, right? So let's go to configure, not here, run configurations. This is lesson 24. This is the main class, but let's look at the argument. See, in the argument I said, I am giving to you the class HR browser. Please introspect it and print and tell me what you see inside. That's from the command line. So in that class HR processor, it figured out that there is a method get employees, and parameters of this guy are SQL statement is, so let's start from employee blah blah blah, and then it has a method update data, and of that guy, the SQL statement was update employee. Right? In the first case, notifying updates was false and transaction required false. In the second method, it was true and true. Again, let me open it up. Not HR browser. See, the first annotation is exactly what we printed without the second and third parameter. In the second case, it has 3 parameters, and we printed properly the update statement. So we can discover the internals of a class. We can discover if there are some annotations. And if we were smart enough to write annotation processor, we would do something about what we discovered. But we are just Java juniors so far, so we cannot even go there. Not just yet. This is I'm showing you how you need to run this annotation processor. We did all that. And the homework. Do the assignments, lesson 23, 24. If you are bored, if you have too much time, then look at some libraries that exist online. Apache Commons has a bunch of libraries for Java with useful stuff, not necessarily related to our topics, but something that is interesting. Another Guava is a library with useful components. Write a program and use them. As an extra challenge, I want you to spend some time and learn about regular expressions. Regular expression is a topic that is not something that's easy to memorize, but you need to understand the concept. Regular expression allows you to find quickly stuff inside the big text, or maybe find and replace stuff. So this is something that is good to know. I'm just saying you what to do if you are really bored. And if you are done with all that, keep reading. There's lots of good stuff in there. By the way, if you are into GUI with Swing, there's a library called JGoodies. For many years, they created a bunch of useful components. So if you want to create Swing applications, that's the way to go. That's all for today, guys. It was Yakov Fein with Farata Systems, and it was lesson number 13. And this lesson actually concludes the Java SE section of our course. We're going to have 5 more lessons, but all of them will be on the server side, about the server side, about something that is called Java EE. Thank you for watching.